In this video, I want to talk about the causal relationships that you will use to draw any and all relationship maps that you do. And I'll explain in the midst of this why this is version 2. Some people, when initially introduced to relationship maps, are a bit overwhelmed, though I hope that you will find that the way this is presented, there are only two causal relationships, and you should look at everything else that you build very similar to building things with Lego blocks. You have a couple of simple blocks and you can just build a myriad of things out of those. So in terms of the relationships themselves, the first one is A adds to B or B changes in the same direction as A. The adds to is pretty easy, though same direction means that if A increases, B increases, and if A decreases, B decreases. As to why this definition is overloaded and says adds to or same direction will be evident in just a couple of minutes. The second form of relationship that is possible is A subtracts from B or B changes in the opposite direction of A, meaning that if A increases, B decreases, and if A decreases, B increases. Now, to clarify the difference between the two of those, let's use a small example. Consider if the relationship between revenue and profit. If revenue increases, profit increases. Now, when we think about understanding the relationships, what we do is we attempt to understand a relationship between two entities and ignore the possibility of everything else in the world being there. We simply think about the relationship between these two entities. Don't think about what else might influence profit at the moment. Simply think about the relationship between revenue and profit. So if revenue increases, profit increases. If revenue decreases, profit decreases. The alternative, or another relationship, is between expense and profit. As expense increases, profit decreases. And as expense decreases, profit increases. Now, the relationship between profit and cash is slightly different. If profit increases, cash increases. If profit decreases, cash still increases, but just not so fast. So that in this instance, profit adds to cash, as opposed to in the same direction. The reason being has to do with the nature of cash itself. Cash is something that can accumulate. Think of it as similar to water in a swimming pool, or lake, or water in a lake, or coffee in a coffee cup, or change in a jar, whatever. It's some amount of something that accumulates over time. Whereas profit is an instantaneous kind of thing. And if you think of the difference between the two of these in instances where time would stop, there would be no profit, but there would still be whatever there was in the cash drawer at the time that time stopped. So you can tell the difference between them. And sometimes it's a little annoying that the definition is overloaded, though it's appropriate to realize that there is a difference between those things which are instantaneous and those things which accumulate. And remember the part about over time, because it doesn't accumulate instantaneously. It generally takes a while to create the mountains of garbage in the dump. Usually takes even longer to get rid of it. So that while the trash collection happens on a day-to-day basis, the trash in the dump accumulates over time. So that's when you look at this whole set of relationships, you see that the difference between revenue and profit is instantaneous, and between expense and profit is instantaneous, but between profit and cash is an adds to relationship. Now, if we simply take these two relationships, you can combine them in two different ways to make more complex structures. Think about what happens with the principal in a savings account. After some delay, it creates interest. Not nearly as much interest as we would like with the interest rates these days. And once it creates interest, the interest is added back to the principal, so that the principal gets larger over time. Well, the interest gets larger also because it's a function of the principal and the interest rate. And I just chose not to show the interest rate on this diagram. The interest rate is sort of embedded in this element someplace. So if you look at what happens, this relationship actually presents a characteristic of growth. It's actually exponential growth. And it's a characteristic that you don't find in principal and interest alone. It's only the interaction between principal and interest that produces this characteristic of growth. We referred to those kinds of things as it's an emergent characteristic of the relationships. If you take the relationships away, the principal is just a stock. It's like cash. It's just an amount of stuff that sits there. But with the relationships with interest, it grows over time. Now you could actually run a reinforcing structure in reverse. Consider that the Cold War reduces trust, and trust would increase, well, trust itself decreases the Cold War, so that this is a exponential decline structure. Previously, I had a bad example here because what was here was a directional label. The guidance is that you should always use non-directional noun or noun phrases as labels, because it gets really confusing when you talk about increasing and decreasing, declining interest or business decline or whatever. If the labels are directional and you're modifying the direction of a directional, it just, I don't know, it makes my head hurt, and it's probably confusing to anybody else that tries to read it. So please heed the recommendation and try your best to use non-directional noun or noun phrases as variable names, and keep them as succinct, as short as possible, so they convey the meaning that you intend. And if it isn't sufficient in the lecture about Insight Maker and the one about Kumu, it'll talk about how you can add comments, descriptions to the relationships so that other people can better understand them. The second structure has to do with looking at a situation where I have some goal that I want to attain. I want a full tub, and the current thing is I have some level in the tub, probably starting at 0. It is the difference between those two that creates a gap. Now, in this example, the assumption is that this is larger than this, so that if I was to increase this value, it would increase the gap. And if I increased this value, it would decrease the gap, which is why one is blue and the other is red. Now, that gap is actually the impetus for some action, in this case, add water. And the add water causes the tub level to increase, which decreases the amount of the gap. And once the action actually causes the tub level to reach the goal, the gap becomes 0. And there's no more, and you don't add any more water. This is referred to as a goal-seeking structure, and the structures are labeled so that it helps other people get a sense of the intent of the structure overall simply by looking at the label. Reinforcing structures, which always promote growth of something, are typically labeled R for reinforcing and a number, and with whatever it is that it's causing to grow. In this case, it probably should have been R1 savings, because that's what the principal is. In this one, it probably should have been R2 Cold War. Here, because it's a balancing loop or a goal-seeking structure, it's labeled B3, fill tub, and it's the fill tub that's the objective of this structure. It attempts to create a balance between the goal and the current level by changing the the current value in the direction of the goal. The way that you tell one loop from another is you count the number of opposite influences in the loop. If it is 0 or even, it's a reinforcing structure. So here there are 0 opposite relationships, so it's reinforcing. Here there are 2, so it's even. Here, when you walk the loop, there is 1, so it's odd, so it's a balancing structure. In a given loop, you may have, I don't know, 4, 5, 6, 10 elements in the loop, so that it takes time to walk around and count the relationships to figure out whether it's a balancing or reinforcing loop. And in the examples presented later, there are numerous models with the loops labeled, so you'll get a better sense of that from there. So hope you found this informative. Just take away the idea that while causal relationship maps can become extremely complex and appear complicated, they're all created from 2 simple relationships. It either adds to or changes in the same direction, or it subtracts from or changes in the opposite direction. Those 2 structures, those 2 relationships, are used to create 2 basic structures, a reinforcing structure and a balancing structure. And any relationship map that you create is simply some number of reinforcing and balancing structures interacting together simultaneously. Now, note that there are a couple of different notations for relationships. One is the plus and minus notation, which is very, very old. And then the other one is the S and the O notation, popularized by Sengi in the 5th discipline, the Art and Practice of the Learning Organization. In the external references, there's an article by Richardson that talks about the problems with causal loop diagram labeling. It's well worth the read, so I recommend it highly. So I'll see you in the next video. Bye.